Hi, my name is Krzysztof, and I'm here to talk to you today about artificial intelligence and using large language models. I work as a principal research engineer at Microsoft/GitHub in an organization called GitHub Next, which I will tell you a bit more about in a moment. There is one small star in this talk. I'm not a data scientist. If you're a data scientist, you probably will be really disappointed in what I'm going to talk about, because I'm going to talk about not AI, not math, not neural, whatever it's called, I don't know. What I'm going to talk about is how to use those large language models to build real-world applications. So as I've mentioned, whoa, what was that flickering? Let's ignore that. I work at an organization called GitHub Next. We are a small team at GitHub, about 15, 16 researchers and software developers, and we are responsible for investigating the future of software development. We try to go where no one has gone before. Well, at least in the context of developer tools. In my presentation, there will be those QR codes and a couple of slides. They are just links to the more details about stuff that I'll go to talk about today. This one is to our webpage. What we do is we try to build prototypes and proof of concepts for future tools that you may or may not see in the future being developed by Microsoft or by GitHub. We had a couple of successes. Probably the most successful project that you may have heard about is GitHub Copilot. So yeah, I think that's a pretty successful one. What is interesting about our projects is that nowadays everything is about AI. AI is the most hype buzzword everywhere on social media, but also in the rooms of C-level executives. So we do a lot of AI. And again, I'm not a data scientist. We have some data scientists in our team, but vast majority of us are just software engineers, as I imagine most of us in this room. And we live in this really interesting point in the time in software development where you don't need to be data scientist. You don't need to have PhD from maths to do AI in your applications. That hasn't been a case 5 years ago. 5 years ago, AI was around, but you had to train your own models. You had to be really smart about that stuff. You know, data science, big data, all that buzzwords from 5 years ago. And that's not me. But right now, we are living in this wonderful world when the models are there. They are just single API call away. We can use them. There is OpenAI, there is other alternatives. Because reasons, we are mostly using OpenAI for our projects. Like a lot of green reasons. And again, we build prototypes, we build proof of concepts. To create a product, real world product that is deployed to the users, it's a lot of work, especially at such big organizations, such big corporation as GitHub/Microsoft. You know, there's plenty of those like project managers and product owners and all those people that figure out how to sell this project that we've created to you. So you pay a lot of those green reasons to us. But I don't care about this. I care about what happens in the middle. So today the talk will be divided into a couple of parts. First of all, I will do a really brief, short introduction to large language models. If you haven't heard anything about what those are, I will try to explain in a moment in a couple of words, which probably my friends, data scientist friends, will kind of rage at me after watching this video. Then I will talk to you about prompt engineering, which is another hype buzzword that you probably all heard about, which is basically the way how we communicate with those AI models and how we convince them to do some useful stuff rather than do silly stuff, which happens a lot. And after that, I will also try to go into a couple of cross-cutting concerns, like how do I know whether the stuff that I've just built is useful? This is a really good question to ask. Trust me, we had a bunch of problems with that before. Also, how to design user experience with those artificial intelligence models, because those artificial intelligence models create certain, they have certain features which require us to maybe create user experiences in a way that allows people to understand that this information is not 100% accurate, or this information may be totally false, and so on, so on. So a brief introduction to large language models. If you haven't heard anything about large language models, what you need to do is those are AI models, ignore that part, that have been trained on the billions and billions and billions lines of text from the internet. In Reddit, blog posts, like Twitter, all the stuff that you can imagine is there. It's probably not great, but it's there. It does stuff. Those models are probabilistic. Before that, those models, we communicate with those models with text. We push a bunch of text into it, just a string, and it comes back with a bunch of text to us. There is no special magic behind the scenes. There is so there is magic behind the scenes, but for us, it's just single function call, single API call. Push string, get string back. Those models are probabilistic, which means that they try to figure out what is the most probable response that we want to get. That doesn't mean that this response is correct. Obviously, we probably all have seen all the weird examples from ChatGPT, right? That it says really weird things that are absolutely not true. But also what it means is that if we send the same inputs to the model, it may come up with different responses every time, because those models are probabilistic. And yeah, there are large models, which means that hosting them on your own is difficult or impossible for vast majority of organizations. That said, with OpenAI providing API, with Azure providing API, it is nowadays possible. Other providers are doing that as well. Probably the kind of like one of the features that you must understand about those large language models is something called context space, which is basically the amount of stuff you can push at this model that it is able to understand in single request. Those models don't have any kind of memory in between of requests. So you do one request. When you do next one, the model doesn't remember what it did in the first one. So you need to push all the information. For example, in context of chat, it's conversation that has been happening as a part of this single prompt, single request. There's a bunch of versions of those models. So this 4K, 8K, 32K, this is the number of tokens. Token is around 2 or 3 characters. It's kind of like some unit of measure used internally by the models. It doesn't really matter too much. But what you need to remember is that this context space includes both input and output. So the more stuff you push into the model, the smaller can be response. So it's not like you can use 8K for the input and 8K for the output. No, it's input plus output equals maximum 8K or 32K tokens. Also, another thing that you need to remember is that the more stuff you push into the model, the longer it takes it to process, and the more expensive it is to process. When you look at the pricing page of the OpenAI all operations are per token. So kind of like each token that you push into the model and each token you get back from the model, this is the whatever amount of green reasons you need to pay to someone. And it has huge impact on the latency. So the more stuff you push, you may think that using the biggest possible models is always the best choice, but that's not really correct. That's not always correct. The more stuff you push into the model, the slower it will be to respond to you, and the slower it will be to process the input and produce the output. So there is a lot of kind of like, pros and cons for using different things. Another buzzword, a bit more AI community, I guess buzzword from AI community is this RLHF thingy, which is reinforcement learning with human feedback. It's basically the idea that you take this model trained on this like unlabeled crazy amount of text from the internet, and then you do additional training step using actual human in the loop. So that's how ChatGPT was created, right? That was there was this like information that there was like a lot of contractors used to produce kind of like conversation data that then OpenAI has used to do this additional training step. This is important because models that are using this technique characterized with way better capability to follow instructions. So normally those models are just finishing your sentence, like in Copilot, finishing your line of code. However, models trained with these capabilities are way better at also following instructions, so you can tell it to do something, and then it will not only try to finish your sentence, it will try to finish your sentence or provide a new sentence, having in mind, quote unquote, this instruction that you gave. So this is bunch of models from current generation of OpenAI. It doesn't really matter. Like there is a link to the pricing page. If you will try to start using those, you will quickly see that some of those are ridiculously expensive, and some of them are good enough to do work. So now let's talk a bit about prompt engineering, and it's another buzzword that we probably have seen. There is a lot of buzzwords in this space, and there is also a tendency to call obvious things with weird names in this space. So we'll see that in a moment. But prompt engineering is basically a way to steer the model's behavior without retraining the model. Training the model is hilariously expensive thing. It's gonna cost billions of dollars probably on the scale of GPT-4. I don't know, don't quote me on those numbers. But it is really expensive process. Fine-tuning is possible, which is just like taking existing model and kind of like training it with bit additional data. But it's also long and possibly error-prone and expensive process. So prompt engineering is a way to steer the model's behavior just using the input data. So just using the prompt, the string that we can send to the model. And there's a lot of people diminishing that on the social media, saying, oh, it's just sending sentences to the ChatGPT. But in reality, there is a lot of engineering in here. There is also a lot of kind of like art in it. So yeah, it's really dynamically developing space. Basically, every day you can find new white paper about some new technique that is used. And I will try to, and this is the link to really amazing blog post that is kind of like go-to source if you are just starting with using those models. Author of this blog post is kind of like having similar approach to me, that yes, there are all those white papers, but half of them can be summarized in 3 sentences. So that's what this blog post is about, that you don't need to read 15 pages of white paper. Instead, you just read 3 sentences of summarize and example. So here is the perfect example for this space loving to, and I'm sorry, I'm not sure how visible are those screenshots on this projector, but we'll deal with that. So here is a perfect example of this space loving to call obvious things with weird names. So there is something called zero-shot prompting and few-shot prompting. Few-shot prompting basically means that you provide examples of how you do things. Yes, it definitely needed a confusing name. So on the right-hand side here is an example of zero-shot prompt. I just give model some task, and it tries to answer, but it has kind of like no context, no idea how exactly I want it to answer. It produces the correct result, but in a format that is not useful to me. Here I provide the model before sending the real task, which is happening here at the bottom. This is what I want to actually achieve. I provide a couple of examples where I send what was the task, what was the answer, what should be the answer from the model, what was the task, what should be the answer from model. And thanks to that, model is able to follow the pattern of how to do things and how to what is the context of what we are working on. So, for example, all those examples here are about command line commands, so like find and ls and convert and ps and all those like typical command line utilities that you can use. As I've mentioned, the models are fairly good, especially the models that are using this reinforced learning with human feedback, are pretty good at following instructions. So, for example, here at in the above, there is an example of, I just give some input and kind of word sentiment and semicolon, and model figures out whether it's what it should do. And the response is obviously wrong. But model kind of didn't know what to do, so it kind of just guessed, basically. And here I give it instructions, please label the sentiment toward the movie, whatever is the instruction. And in this case, the model was able to correctly figure out the sentiment that it should return. This technique is really good in cooperation with the few-shot prompting. So if you have kind of like multiple instructions or kind of like multiple examples of how to handle some kind of instructions, pushing that all into the prompt is a great idea. Models are getting pretty good at returning you structured output. So, returning text is awesome and may be useful for some cases, but in software development, we want to integrate with real systems. Real systems obviously use JSON or YAML or, those two only. So if you instruct the model to return the response in the format, and then maybe you can give some possible enumeration of the values and things like that. The models are pretty good at following that type of stuff. So that's the way that we can integrate pretty easily with the existing systems. That's the way where we can validate those responses, right? Because if it's JSON, we can easily parse that. We can validate whether it actually is sentiment is only negative or only positive, and so on, so on, so on. So that's a pretty interesting technique. The really confusing thing and really interesting technique is this thing called chain of thought. And again, in the spirit of we love to name things in a really confusing way, what it means is just giving a model an instruction so it kind of like goes step by step by the process of how it achieved the result. So rather than just giving you the final result back, we ask model, let's think step by step and give the model space to express itself, to provide you explanation point by point of what it was doing and how it achieved this result and what was what were the steps in the middle. I don't really understand why it works. It works. It's again, there are white papers about that stuff. You can find them. A lot of things that I'm talking here about, it's just pointers for you. pointers for you. It's kind of like you will know after this talk, hopefully, if you would like to do AI application, you will be able to have those like words, like chain of thought in your mind somewhere, and you will be able to look for them in GitHub. I'm not giving you like ready recipes because there is no really ready recipes here. And there is also a whole bunch of other buzzwords. Again, things that sound terribly scary, like self-consistency sampling, which is a really scary way of saying that we should ask model multiple times what is the result and then vote, like use majority vote, for example, to decide what is the right result. Self-ask, which is similar to the chain of thought, where in the chain of thought we ask model to explain the process step by step. With self-ask, we can ask the model to ask some additional questions to itself about like what's the process and what's happening. Tree of thoughts, which is more complex way of chain of thoughts when we actually make whole like trees of the decisions. It's confusing. Equipping with tools. So this is also really powerful and popular technique nowadays. So we basically try to allow model to communicate with existing systems. So the model can get additional information if it needs, or can perform some actions if it needs. So for example, it can query database, or it can query internet, or it can query, or it can perform any other, it can perform other actions on behalf of the user, which is kind of like transparent, invisible to the user. Those are often multi-round systems, so it's multiple requests to the model happening in chain of the request. We do one request, we get result back, we perform some operation on the result, we put all the previous context and all the new context into the next request, and we do another request. So those are more and more complex systems that we try to create with those AI models. And again, it's really quickly developing space. Basically every day there is someone new coming with some new idea, new technique, new stuff that they do. They publish white paper because that's obviously the most important thing you can do in software development. Not create real products. Publishing white papers is the way. That also brings us to this another buzzword, which is called retrieval. This is probably the most popular buzzword in the rooms of the C-level executives at Microsoft nowadays. Don't tell them that I've told you that. If you have phone number to Satya, please don't. No, don't. Basically, this couple of techniques that I've talked so far about were mostly about static parts of the prompt. So preparing examples, preparing instruction, making sure that model returns the output in a structured way. However, very often we want to put the context from the current user's work stream, from the current file that you have open in your editor in context of like Copilot or stuff that we do, or context from the current repository that you're working on, and so on. So the general name for all those various techniques doing that is called retrieval. And again, there is no single definition. There is no single way to do that. It really depends on what your project is doing. It may be querying database to find relevant information. It may be querying internet to find relevant information. It may be looking at what has been past actions of the users in the current session, for example, to figure out what is the right information. And the one thing connected to that is something called embeddings. Embedding is basically a numeral representation of the meaning of the sentence or text. So it's under the hood, this is just a list of floating numbers. It's like vector of floats, if we talk about it in like software development terms. This is created by using separate AI models that you send some text, and this model creates embedding for this text. Again, OpenAI, Azure, and all other providers are providing those models. What is interesting about embeddings is that it encodes not only like word-to-word meaning of the text, but also the more general understanding of what this text is representing. So this text is talking about software development and not only just word. It's not word-to-word translation. It also contains general meaning, which means that if we have two texts and we have embeddings of two texts, we can then calculate the distance between those embeddings. They are just vectors of floating numbers, and calculating the distance between those is kind of like math. There is libraries to do that in every possible programming language. And then if the distance is close, that means that those sentences are related to each other. This is super important for retrieval. You can imagine a scenario. I will give you a scenario from one of our projects, where you ask a question about documentation of certain open source project, let's say React. And under the hood, we have database of those embeddings, where we calculated those embeddings for all the content of React documentation that is online. So we can find those parts of the documentation that are related to your question. So we can provide you with direct pointers, not only with some text response from AI with bullshit, like it's like blah blah, and it's doing something. But we also can provide you links directly to the parts of the documentation that answers to your question, and other things like that. So this is really powerful. And again, this is complex topic. There is some link to somewhere. I don't remember what is this link. Sorry. So that has been kind of like really quick run through various buzzwords and various techniques that you could use to use those large language models with your applications. However, there is also other part of the equation, the part of the equation that is maybe even more interesting. How do I know that this thing that I've just created is good at all? As I've mentioned, those models are probabilistic. You cannot just run the unit test at your machine and be kind of, okay, it's passing, because that's probably will pass in maybe 60% of cases, or if you're lucky, that's good result. Or maybe the model will respond in slightly different way. Yes, it has the same meaning, but kind of like the words are slightly different, so you cannot really easily unit test that. Or maybe, maybe your system is a chat system, and then, evaluating chat responses in unit tests is kind of like really difficult and kind of like probably impossible. So there's a couple of important things here. Basically, for every project we've done, we've built offline evaluation benchmark tool, which tries to run something like unit tests with some measurements, but on the scale of tens of thousands, hundreds of thousands examples on CI server or potentially on your local machine. And then the way to observe those is looking at the percentages, right? It's all about percentages. How many scenarios were successful? What's the percentage of the scenarios that were successful? Not looking into particular cases, because judging particular cases with probabilistic models is really difficult. So, for example, in case of Copilot, we've built this system where we take a public code from the internet, Python repositories which are using Python testing framework. We take repositories with good test coverage. We take all the code that has been covered by those unit tests. We remove bodies of those functions that were tested. We try to regenerate them again with Copilot, bodies of those functions we try to regenerate with Copilot, and then we run the tests again to figure out whether the implementation, or figure out whether Copilot is able to recreate the implementation. And again, this may be wrong for case A or case B, but if you run it on hundreds of thousands of examples, because there is a lot of Python code, there is a lot of unit tests, there is a lot of functions, you can run it on really huge scale. Then you can kind of like just count the numbers, see what are the percentages. And So this is kind of like, in my experience, seriously important whenever you build an AI tool, to build the system that helps you move forward. Because if you don't have something like that, you just don't know what your changes to the prompt mean. Like, I mean, let's say we've added chain of thought prompting to our prompt, but if we don't have any way to measure what was the impact, like we don't know if that was good choice. And another way to measure results is running A/B experiments on the users. I know that telemetry is a not super popular topic among software developers. We don't like telemetry. Like, I don't think. Is there anyone in this room who likes telemetry? No. Yeah, me neither. But with those AI projects, unfortunately, we need to do that. Especially at the early stages of the projects when it's still technical preview, in our cases, technical previews. We need to understand how users are using our systems, and we need to understand what is the impact of the changes that we are deploying to the users. So having the good A/B experiment framework inside your application is also really crucial. And there is one kind of like caveat here also, 1 star. More accuracy doesn't necessarily mean more value in your system. You can create the AI systems with really high accuracy, but they will be too slow to use, or they will be too expensive to use. You need to find balance between what's the value that your system brings to the user and the accuracy. As I've mentioned at the beginning, there are those GPT-4 models that are super powerful and super good at what they do. That said, they are not really good choice for every use case. It depends. Are there a lot of software consultants in this room? I know it depends is our favorite response to any question. We've done a user study on the Copilot users, and we found out that users are happy even if the suggestion is slightly wrong, as long as it pushes them in the right direction. We probably could make the suggestions better, but if they were slower, if we shown less suggestions to the user, if we shown them in less cases, in less positions, that's probably less value to the user, even if those suggestions were slightly better on itself. So that brings us to the question of the user experience design with those AI models. What is important is that you need to design defensively for the failure. Those models will fail. Those models will give you the bad results. Those models will give your users bad results, bad suggestions. We need to design user experience in a way where it's easy to ignore if the suggestion is wrong, or if the outcome of the AI system is wrong. We need to make sure that it's easy to retry, because again, those models are probabilistic. Maybe user want to just retry with the same context. We need to make sure that user can easily iterate on the result. So they accept result, but maybe they slightly change it, or maybe they reject the results, but they add additional context to their next query. Let's say it's the chat system. We also should make those systems be able so users have capability of easily changing the result. So not kind of like, those systems shouldn't kind of like, generate something for user and then kind of like, commit the operation to the database or something like without giving a user a chance for any feedback inside. What is the most important is that user should be always in the loop. Those systems are not replacing users. Those systems, in our case, are not replacing software developers. What we want to do is we want to make life easier for our users, for us. So we need to design for that. There is a couple of standard techniques or kind of approaches to the user experience that you can use here. One is this thing we call optionality. So it's bestly shown with Copilot. If the Copilot suggestion is wrong, you can just keep typing and ignore this like inline ghost text thingy. the same may be true for your system. Maybe it's kind of like helping user with some queries, or maybe it's some data analysis. User are trying to do some data analysis, and you may suggest them some query, but as long as it's easy to ignore, then it's fine. Another technique is transformation. So, for example, maybe user needs to select some code and click some button to do something. This keeps user in the control of like what is the context of what user is working on. What is the exact command I want to make this whole code uppercase. Well, that's a silly example, but you can find something. I want to refactor this code to modern JavaScript from old JavaScript. User is always in the control, so that's the most important thing. And the iteration, it's like all the chat interfaces that are everywhere nowadays. I'm not the biggest fan of the chat interfaces, but they are working pretty well in some context. They give user capability to iterate on the results. If the result that AI gave to the user is not 100% correct, user have option to provide additional context to the model. This only works if your user is kind of like expert on what they are working on. So those are usually interfaces that work better with experienced users. If I go to ChatGPT and ask it some question about biology, I have absolutely no idea whether the answer was correct. So I cannot provide more context to the user. If I ask a question about F#, which is my programming language of choice, then I can provide. If the answer is not 100% accurate or not great, I can provide additional context to the user, to the model, so the model can try to come up with the better responses. So all those three options have their like pros and cons. Again, choosing them, it really depends on your use case. Like I cannot give you any like ready recipes for how to build the AI application. I can give you some examples of building blocks that you can use. Interesting question is, those AI models give you capability to stream results. So instead of waiting for a whole block of text to come back, they can give you results back token by token, word by word. This may be a good choice for some types of applications. In case of Copilot, we want to show you whole suggestion at the same time, because when you see it, when you accept it, you kind of need to know what is the thing that you're accepting. But if it's some larger text that you're returning from the model, ChatGPT answer or kind of like answer about some documentation question, it may be good enough to stream, and that creates this feeling of like, oh, there is text happening, there's something happening on my screen quicker than with all at once mode. So maybe streaming allows you to use more powerful models, because again, those models are in general slower. But if you use streaming mode and you're able to use that mode, maybe that will be good enough for your case. There is no single path to the success in this world. So I cannot. It's just like with software development. Like I cannot give you a recipe for like how to build every single software development project in the world. I cannot give you a recipe what frameworks to use. I cannot give you a recipe on what methodologies to use. We have different opinions. We have different cases. It all depends. That said, I hopefully after this really quick introduction to the space, you will be able to get here. There will be a whole mountain. There will be. Like it's not easy space. It's space that's, again, moving fast. It's space that's still experimental. There is not a lot of user case studies in the internet that you can kind of like copy. There is not a lot of best practices. It's really on the edge. But if you want to do it, hopefully, after this talk, you will be able to reach this point, and then you will also know where to look to go further. That said, there is still one probably most important question here. Should I even do that? Should I integrate AI with my system? And this is the basic question that you need to ask yourself, when kind of there is some like decision maker, C-level executive coming to your team and telling you, oh, AI is hype nowadays. We need to have AI in our product. This is the main question that you need to ask yourself and your product owners and your business people. Should we do that? Is your system okay with giving user potentially wrong responses? Those models do hallucinate. They do give people wrong responses. It's really important to remember that. If your system is helping people calculate your yearly taxes, please don't use AI. Really, please. If your system is helping users with the health issues, maybe not the best case. If your system is showing some text in your IDE, yeah, that sounds reasonable. So you really need to think really hard about what's the value and what is the value that it will bring to the user, and what are the risks that you expose your users to with those AI systems. So I guess the main summary is don't take everything that ChatGPT answers to you as granted. Probably the best way I've seen it described is by one of my colleagues who described ChatGPT as AI for entertainment. So remember that ChatGPT is entertainment. It's not kind of like source of knowledge for everything that is on the internet. And I think that would be it. Thank you for watching. It was really a pleasure to be here. And if you have any questions, I'm happy to answer right now. If not, then I will be around. Okay, we have questions. Can we get Mike for the question? Yeah.
Thank you. Given that these new chat bots are now enabling stuff besides text, how is that going to affect the token consumption? Like when you upload an image and you ask it to describe an image.
Can you repeat, please?
Sure. Given that these new chat models are now allowing you to use other things other than just text, when you upload an image and ask it to describe the image, how is that going to affect the tokens?
I don't know. No, sorry, I don't know. I don't know the answer to this question. Any other we have? Yep.
So, for example, in a particular case of the GitHub Copilot, so there are always like new frameworks coming up or like new ways of doing things in programming. So how do you adapt, or how does it work when you actually need to change so your language model? But if you are using OpenAI, it's not yours. So what do you do?
Yeah, so this thing I've mentioned, this retrieval thingy that I've mentioned during the talk, where you put outside context into your prompt to be used. And by the way, this is a really good question. This is the way how we solve those issues. So yes, the model may have outdated knowledge. The model may not know latest version of the framework or the language. What we found out is actually that in most cases, it's better to not depend on what model remembers, because it might be wrong. We try to put as much context as possible, given the performance characterizations we want to achieve, into the prompts. So for example, in case of programming, in case of Copilot, we put like other code from other open files in your editor, for example. So if you started already using this like new version of the library in some other file in your project, then it kind of model will be capable of like picking this up, hopefully, and noticing that something is weird and something is different. Those models are really good at following patterns. So if they start to noticing that there is some pattern in one place in your code, then hopefully they will also try to come up with this like new version of the API, whatever. It's not 100% accurate, but also you can imagine. I don't think we do that anymore. So I don't work on the Copilot team anymore, so because that has been given to the main GitHub engineering, so I don't really know 100% what they are doing. But you could imagine a world when we actually read the package.json or like cargo.tom file and check what is the version of the library that you're using, and then maybe look for the documentation for this library somewhere in the internet. Again, it's kind of this giving tools ability, giving AI models ability to use external tools to do this retrieval is probably the way we want to solve such problems. Okay, any more questions?
Thank you for the great presentation. I have a question. If I understood correctly, there is no memory between prompts. So the system doesn't know, there has no context between prompts. Yes. So the step-by-step approach here, how do you ensure that the step-by-step approach does not lose context between prompts, or is it the step-by-step approach, one prompt with the steps on itself?
Yes, so this chain of thought step-by-step approach, this is used inside single prompt. It's just about giving the model space that it reasons on itself on the task that it has been given. So that's for some random reason. Well, there are reasons. That's for some reasons results in better responses. If you want to keep the context between the calls, you need to put that into the next prompt. You need to put the context that you want to keep between the responses into the next prompt. We do that sometimes. There are some projects where we put whole previous prompt with whole previous response into the next prompt. So there are cases like that you can do if you really want to keep the context.
That makes sense. Thank you.
Any more questions? If not, I need to plug two things. One is the book at the O'Reilly. It's in early release, really, like there is first two chapters ready that has been created by my colleagues from GitHub. It's being written as we speak, which is, again, a lot of the stuff that I've talked about in way more details than I've talked about, and probably in way more comprehensible way. Everyone took photo? Okay. And then second thing is a report for O'Reilly created by my friend Philip Carter from Honeycomb, so the open telemetry people, about observability for large language models. Also, if you Google Philip on the internet and Google Honeycomb on the internet, they have really bunch of really good blog posts about actually using AI models in production. I've mentioned that there is not a lot of case studies or stuff like that. They are one of the best sources of the case study that I know of right now, other than stuff at the github.com blog. Cool. Thank you a lot. It was a pleasure. My name is Krzysztof, and it was great to see you here.